morning, everybody. Like she said, my name is Rodney James from Duke Energy. We're a utility here in North America. See if we can. Awesome. So basically, what I'm going to talk to you about today, as I get things set up, is our work with augmented reality and virtual reality, and then also a little bit of work with artificial intelligence. And as you can see, our work with the Now robot I have over here on the right-hand side. I do want to level set a little bit of expectations on it. I will have there will be some video in the presentation on kind of the work that we've been doing with Now, but I like to also say that I did register some concerns with my boss on the power company working on AI and building a robot. And if you're not familiar with that reference, just check Arnold Schwarzenegger's Greatest Hits. So Duke Energy, largest utility in North America. We have about 52 megawatts, no, 52 gigawatts in generation. We operate in North Carolina, South Carolina, Indiana, Ohio, and parts of Florida. We have about 7.5 million customers that we serve in each of those areas. All of those areas have different jurisdictions in the way that they operate, and regulated and unregulated, so that also usually presents a challenge. Emerging technology, which is the group that I'm with, and a couple of our folks who are here. You heard the keynote from Jason Hanley, who's our director. We work as a R&D shop for Duke Energy. So we look at technology from a hardware or a software perspective agnostically. So we want to just look at what are those practices that are going on in the industry, what are those things that are happening that are going to be going on within about 5 to 10 years into the future. One of the important things that we always like to explain to folks is that we don't have a hand in operations. So the technology that we look at and that we work with, we are not necessarily tasked with how does this then make money for Duke Energy, or how is this going to be something that we take into operations. We will inform our internal group, our grid infrastructure group, and our grid and technology group of what we have learned, but then it is their responsibility. We usually then work as subject matter experts with those groups in how they can take the technology or the operations learning to an operations standpoint. So what I'll just kind of walk through today is, again, we talked about the Emerging Technology Office. I'll speak a little bit about the work that we've done with augmented reality and virtual reality, smart glasses, and then we'll talk a little bit about artificial intelligence, and then some of the work that we're going to be working on trying to combine this into the future. So we started this work, and I can't take all the credit, with another gentleman, Alex Vukiewicz, who's also in our Emerging Technology Office. We started this in about 2015, where we looked at smart glasses, and we worked with just live video and audio and GPS location. One of the things that we found is that the GPS locator that you have in your phone is not as precise sometimes as we really want it to be. So that was a learning that we had, that we took forward, and saying, can we get more accurate GPS devices, and how would we implement that in our efforts in working with smart glasses. The next is live video and audio with remote assistance and annotation. So the idea that if I'm a new technician in the field, I see a piece of equipment, instead of radioing back for another technician to come in and help, can we just have a remote assistance at the home office, so they can see what's going on and they can help the technician through that. That presents a safety plus for us, because that's only one person that we're engaging in an electrified space, and then also too, we eliminate an extra truck roll for us. Then the next is the next thing we worked on is in 2016 we did live video and audio with workflow assistance. So again, if you're an engineer or you're someone in a nuclear plant that has to go through procedures, instead of having a large document of 50 or plus pages, can you just do workflow through the glasses? Do step A, do step B, do step C. Next couple of things we're going to be working on is live video and audio with GIS and beacon integration. If you've been to our utilities, our operations areas, we have lots of equipment in the field. So can the glasses accurately denote where that equipment is using GIS beacons and things like that? So if you're in the field and you're saying and you want to know where the 50 kVA transformer is, the glasses will tell you it's right over here and point you in the right direction. And that's with an integration with our Maximo database, which is the database that we use for asset accounting and things like that. And then the last is we're going to be working on live video and audio with an O&M procedure and implementation. So again, if you have glasses that can lead you through how do I install a generator, how do I install a wind turbine. Here are some of the glasses that we've worked with. This is not an exhaustive list. As you can see, each of the glasses that are available have different form factors, different interfaces for use. And so given the use case that you would have within your company, it'll depend on the glass type that you use. The real wearers, since they're connected to a helmet, and the Vuzix M300s, those are glasses that have a safety rating with them, so we could have them in hazardous areas. In your Vuzix M100s or your Theer Air or your Epsons, those might be ones that you would just have in a warehouse application. Also, your ODG R7s, they make actually a hazardous rated one as well, so that would be another one that you could have inside a hazardous environment. Here are two technologies that we used to connect kind of the glasses, which are typically most of your glasses are on an Android platform of some sort, and then back to the home office. We used the Theer Air Suite. Again, their product allowed us to do some workflow integration with the glasses just to test that out. HPE My Room, their software allowed us to do some live video and audio with annotations with the annotations on the screen for the user wearing the glasses. This is again not an exhaustive list. There are other manufacturers out there. We just work with these folks initially in working with the glasses. Here are a couple of transports that we would use communications. So with your smart glass technology, it's pretty much your glasses over some type of Wi-Fi that connects to the internet and then to your back-end software. How it gets that transport layer or how it gets to the internet it's going to be solved by one of these devices. Again, we've used a couple of different jetpacks. This is going to be something like the jetpacks are something you're going to use in the field. We're also investigating vehicle Wi-Fi in the truck for our technicians out there. Then again, in building infrastructure Wi-Fi, if you have a plant or something like that, that allows for a Wi-Fi signal inside the plant, and then also a phone or iPod, or a phone or tablet or some type of hotspot that's provided by your phone. All have their different pluses and minuses. There's not always building Wi-Fi in every single location in the plant, so that's one thing that you would have to work through. Here's a simple application again with a Theer Air. We're working through the procedure steps. Again, just in the glasses, you can see follow this next step. Once you have done it, acknowledge it, and then move forward. Instead of having a procedure book that is about 50 or 60 pages large. Then again, this is your live video and audio with annotations on the screen. So again, a technician is interfacing with a piece of SCL equipment, which is pretty prevalent within the Duke territory. They can, the person on the back end of the software can see what the technician is doing and then say, hey, press this button here, let's see what's going on the front screen. So then this is just an example of how we want to put it all together. We want our technician in the field to be able to access all of our back-end systems with our OMS, our PI historians, and our one-line diagrams utilizing a communications network. That communications network can, again, be either a jetpack, your personal hotspot on the cell phone, or vehicle Wi-Fi. But then enabling that technician to understand and be able to deal with a piece of equipment or a procedure step or troubleshoot an issue with being able to connect to our Duke infrastructure on the inside. So then transitioning then over to some of the augmented or some of the artificial intelligence work that we've been doing. We took a small pilot of substation transformer maintenance with about 20 questions and answers, and then we wanted to feed it with 5 from a one-line diagram, 10 from a transformer and O&M manual, and then 5 analytics based on PI data. So again, taking data from different areas, crunching it together, and then giving a logical answer. The project was implemented using deep NLP technology on the Now robot. We worked with Spark Cognition. They worked hand in hand with us, very much so, in developing this. So what I'm going to do now is I'm going to play a video that's going to show some of the work that we've done.
I'm about to start doing the transformer inspection. What's my first step?
The first step is to do the transformer visual inspection. First, you would need
There we go. That's it.
I'm about to start doing the transformer inspection. What's my first step?
The first step is to do the transformer visual inspection. First, you would need to check the bushings for contamination, oil leaks, oil level, general transformer condition.
What's my second step?
Check the transformer for oil leaks.
The oil level gauge is showing low oil level. When did the alarm come in?
The alarm became active on August 1st, 2017 at 1,100 hours.
Did the transformer have any top oil temperature alarm or hotspot temperature alarm during the same day?
No, it did not.
What was the maximum loading during the same day?
The maximum loading on that day was 25.5 kVA or 68.92%.
What is the third step?
Check the panes, any potential bushing gaps, and lightning arresters.
So this is where we use different ways
What
to
was the
speak to
maximum
robot.
loading during the same day?
The maximum loading on that day was 25.5 kVA or 68.92%.
What was the max loading on that day?
The maximum loading on that day was 25.5 kVA or 68.92%.
Is there an alarm on the DGA monitor?
No, it did not.
Does the DGA monitor have an alarm?
No, it did not.
Do I need to check anything else on the cooling system?
You need to check the loss of AC alarm by opening the circuit breaker to the control circuit within the transformer. This should send the loss of AC alarm.
Is there anything on the cooling system that could cause this issue?
You need to check the loss of AC alarm by opening the circuit breaker to the control circuit within the transformer. This should send the loss of AC alarm.
I'm about to start doing the transformer inspection. What's my first step?
The first step is to do the transformer visual inspection.
Yeah.
First,
Stop now.
you would need to check the bushings for
So basically, what that video shows is that we can interface with the Now robot, again, using regular language and still getting the same answer back from the given data that we have that we've programmed the robot with. So now what I'd like to talk about is then just some future steps that we would like to go through as we still continue to do some programming with the robot. So then one of the things that we learned is that we can do interface with Now, and that one of the main things that you could see is that there is a delay, a little bit of a delay with that interface. But what we would like to do is that, and we understand, is that with better processing, better processing and analytics with inside hardware with inside the robot, that's going to get faster. We did find that in our proof of concept that the AI engine is capable of performing data analysis given a set of data. So again, if we can give it disparate points of data in different areas, analyze that data, and then it'll spit back an answer for us. And the last is the AI engine is capable of providing the same answer to the end user given a variety of different ways. So again, we are all not going to interface, or we are all not going to ask the same question the same way, but can we still get the same answer given the question that was asked? A couple of next things we would like to do is a wind turbine generator replacement project. So again, being able to feed instruction steps and understanding into the robot, and then also understanding error codes that's generated by that wind turbine, and then giving that information to a technician. We also would like to feed it analysis on one-line diagrams for our substation. So the idea is that if we had, say, a Now robot in each substation, can we have that robot then just allow that to be pretty much almost like an Alexa for the home, well, a Now for the substation, and be able to do some analytics on what that substation is currently doing, how it's working, error codes, feeders, reclosers, and things like that, to be able to inform our technicians. So other thing we're going to be investigating is the difference between a chatbot versus a cognibot. I like to say the difference between an Alexa and HAL for the substation. If you don't know what HAL is, refer to 2001 Space Odyssey. The chatbot, again, I ask it, I say the catchphrase that wakes it up. Ask the question, and the chatbot gives me an answer. And the cognibot, the idea is that it'll actually tell me what's going on, and then I respond to what the things that need to be done. So it actually is more proactive than reactive. The other is that we'd like to take a whole substation, or not substation, or just any type of O&M manual that we have, feed it into our data analytics to be able to process this information that we can then interact with our AI. And then also have that AI be able to understand real-time analytics on on alarms, on analog data that's going into our Pi, being able to give us an understanding of what's going on in the field, but again, have that happen at the local area wherever it's deployed. And that's all. Thank you.